70 derivative of f of x equals x to the 60. Anyone know right away what it will be? It's okay if you don't. I'm not expecting you to.
0.
Why do you say 0? Okay, so your claim is the 61st derivative of f of x equals x to the 60 will be constant. All right. Now these are really big numbers, so I might have trouble seeing that at first. And what I might do to help myself is I might take a simpler version of this problem and say, well, what's the 5th derivative of x cubed? To do that, if I feel totally comfortable taking if I understand this idea, that's fine. To help myself see it, I might say, okay, I'm going to back up. I'm going to do with a simpler problem. A of x is x to the 5th. A prime of x is 5x to the 4th. Double prime of x is 20x cubed. The 3rd derivative, a triple prime of x, is 60 squared. 4th derivative of x is 120x. So then the 5th derivative of this function will be 120. And so the 6th derivative of this will be, so the 5th derivative of x cubed was the 6th derivative, I changed the problem accidentally. 6th derivative of x to the 5th is 0. Now, is there anything magical here about this process in terms of the numbers 6 and 5? Okay, so you're saying what makes this happen is that 6 is greater than 5. And notice what's happening to the powers. Every time we take the derivative using power rule, the power decreases by 1 until you get eventually to a constant. And then the derivative of a constant that's just hanging out by itself is 0. Do y'all see why that works that way? So your claim that the 70th derivative of x to the 60, that the 61st derivative of x to the 60, I think you said the 61st derivative will be 0 actually, which is right. Okay, so you're saying the nth derivative of f of x equals x to the k will be 0 if n is greater than k. Is that your statement? That's a good thing to investigate. So we have one example where the derivative that we were taking was higher than the power and the derivative was 0. And the question is this always true? So let's see. You're saying, so what are the conditions on n and k here? Because a statement can't really be a precise mathematical statement if you don't know what you're allowed to do with the numbers. So this statement is true for what types of numbers? Okay, so this is a power function, but for what types of numbers? So we saw that it's true specifically for 6 and 5. And what I'd like to ask you is, what if you have a different number? Can you play around with it and see, is it always true? Is this always true for all types of numbers n and k? We saw that basically it should be true for 6 and 5. Now let's test it. There are other types of numbers besides 6 and 5. So you want to do a of x is equal to x raised to the, I need negative values of n and k, or does that even make sense? I can't take a negative first derivative. Where do you want me to make this value be negative? So you're saying try negative, and we're going to make a be negative. So a of x is equal to x to the -2. Now can you give me a value of n that is larger than -2? 1. I can't take a negative once derivative, so let's go with 1. Here I'm investigating when k is equal to 1, and n is equal to 2. Sorry, k is equal to -1. And you said k is equal to -1, n is equal to 1 is what you want to investigate. All right. So the first derivative of this is equal to -2 x to -3. Is that equal to 0? Not 0. So we have our statement, but we know that now it doesn't hold when k is a negative number. Okay, so should we restrict this to say what? Okay, so we at least know it's not always true, and we want k to be a positive integer. Is integer necessary there? So the real numbers are the set of everything, like all numbers that include things like pi, e, square root of 2. It doesn't just include the integers. The real numbers include every number that is not complex. So you have like square root of 2 is a real number. You have pi is a real number. You have e is a real number. Seen it's not true for all real numbers because it doesn't hold for k equals -1, or k equals -1 is a real number. Positive integers would be, there would be 1, 0 is not positive, 3, 4. So when we look at the positive integers here, are these the numbers you mean 1, 2, 3, 4 going up by 1 when you say positive integer? So this is true if k is a positive integer.